today. This is the most important concept in the discrete mathematics. Next, let's see get to the what are the contents we are going to study. What is game theory, about game theory and game theory terminologies which we're going to study, and what's more, we are going to study about what is game theory. Well, game theory is the study of making strategic decisions and modeling the interactions of two or more players. It means that it involves two or more players to play a game. And to play a game, there will be a way, there will be a plan, the plan or the way decisions which we take, which move we should do. That thing is called strategy. Strategic decisions. And we study the strategic decisions, and we will think what strategic decisions we can take while playing the game. That's called game theory. A key aspect of game theory is that the payoffs to one player depend on the decisions that they make. It means that the main important thing is payoff. Payoff. I'm going to tell about payoff in the next slide. But the thing is, the main important thing in game theory is the main important key aspect is the payoff. The every player should have a payoff, and depending on their decisions and depending on their playing, depending on their way to play a game. Okay, let's get to the next topic. To be fully defined, a game must specify the following elements. See, if we talk about the games, a game must have three main points. Those are players of the games. What's players of the game? Says a player, there should be two players compulsory minimum to play a game. Example, chess. If one player plays a chess, then it cannot be a game. The game cannot be continued. Why? If two players are there, it can be continued, right? It will be continued. And if we come to carom, compulsory two players should be minimum, and four players it's like a choice. If we want, they can join. If they want, they can join. Okay, let's get a second point. The information and actions are available to each player at each decision point. What are the informations and actions available? It means that if a player plays a move like in chess, if a player plays the king in the front point, in the front 2 points, if he takes front 2 points, black and white, if he takes front two, then information and actions which he took should be known to the other party, should be known to the other player. Other players should know exactly what he's doing, which strategy he's playing. Or even if he don't get clarity which strategy he's playing, he should know what he's doing at current and how he's trying to make a way in the game, so that he could take a decision, he could take a next decision to what to do to play win the game. Okay, let's see get to the third point, the payoff for each outcome. As I told you, I will tell you in the next slide. Payoff, every player should get a specific payoff, and every player in every game, example, there is two players. First player plays one game and he wins, he should get the payoff. And in the second player plays a game, and if he wins, then he should get a payoff. If he loses, he should get a payoff. Like that, for every game, for every player, there should be a specific payoff. Okay, next point. Next topic we gonna the see about types of game theory. Actually, I'm not gonna be in depth to types of game theory, but I would like to tell that these types of game theory is important concept in game theory. Symmetric and asymmetric, cooperative and non-cooperative, simultaneous and sequential. These three are types of game theories. These three are the types of game theories. Well, the main example in game theory, like these are types, but there is an example in game theory. The prisoner's dilemma. This is the main example in game theory, which like if we tell everything, if we give everything and information, then it's tough for you people to study about that information. That's why it's tough for you to think about the depth of the information. So I'm gonna just suggest that the prisoner's dilemma, you better search about that before I get to the last slide, because in the last slide I'm gonna just tell a small information about prisoner's dilemma. Next, game theory is a branch of discrete mathematics that deals with the study of mathematical models of strategic interaction between rational decision makers. See, as I told you, game theory is what? It's a branch. It's among the discrete mathematics. It's a small branch of discrete mathematics, and it deals with what? It deals with study of the decision making of a strategy, strategies of game, strategies of players, strategies of decision making. It's a fundamental concepts in the field of decision structures. It's a basic concept in decision structures which everyone should know so that it can be used in real life as well. Yeah, you may think, wow, game theory can be used in the real life. Yes, it can be used in real life. There are so many situations it can be used. Example, if we do a perfect strategic decision making in the game, while playing the game according to the game theory, then we can take a perfect decision for our life, so we can exactly go in a best way to achieve something in future. Here are some key elements of game theory related to decision structures. What are those? Let's see what are those. Players, strategies, payoff, normal form and extensive form. Okay, let me give you clarity. Key points, everything is a key point here, okay? Everything is a key point, but except that these three things, player, strategies, payoff. These things are key points. It's like a terminologies. But if we come to the next thing, like if we come to the next normal form and extensive form, and as a Nash equilibrium, zero for games, zero sum games, cooperative games, combinatorial game theory, these things are not key terminologies, okay? These things are exactly the game theories, means strategic, which we game theory. What is the key point of game theory? It's a strategic decision making, right? Yes. To take a strategic decision making, there are many types of strategic decision making. There are many types of strategies. That types are called normal form and extensive form, etc. etc. These are the types of strategies, okay? I thought to put it separately, but it also comes and involves in the game terminologies as well. So I'm merging everything. Players. Okay. As I told you, I don't need to read every slide. Let me tell you, according to my knowledge, players means an individual or and companies or whatever corporation, whoever you take, the team and group of people. Totally, if there is a two groups or two companies or two individuals, those players can play a game, like minimum should be two. Those players plays uh, a game to win or lose. Example, if there is a company, okay, that company wants to take a decision which project to take. Like there is a two company A and B. A company is competing between one project for one project, competing for one project. Then a company should take a decision, so they thought to play chess. However, the bosses are good at chess, so they thought to play chess between keep a chess competition between their bosses, and they play chess. A company wins, then A company to take the project, B company loses. Okay, so that's how players should be compulsory minimum. If it companies or team or group or friends, whoever it is, you play a game, you play a strategy. Strategy is called, you play a plan or a way, or just however you play that plan which you do to win, exactly to win. That's called strategies. Okay, now you know what's plays. Compulsorily two plays should be. Then strategies. It's a plan or set of strategies, or players plan to win in their own way. That's called our actions which they take, decisions which they take to win in their own way. That's called strategy. Okay. Payoff, as I told you, if a person wins, he get the profit. If a person lose, he get the loss. In the same way, if a person wins, winning is a payoff. If a person losing is a payoff. Some members play by betting the money. Some members play by betting some other things, physical or unphysical, visible or invisible. Some members just enjoyment, like friends. Those members just take it as winning or losing. That's it. They won't bet money, so the payoff will be considered as winning and losing. That's it, as a points or something. Uh, and also payoff, it's not like if they, even if they win or lose according, even if you play between friends, there will be thing called points, those points are also considered as payoff. But mostly the payoff are considered more as an outcome, numerical values like money or utilities or something like that, etc. Thank you. Let's we get to the let's stop the key terminologies here and get to the strategy types, and as well as also terminologies. Keep that in mind. Normal form and extensive form. Game theory models can be represented in both normal form and extensive form. See, game theory has two forms, okay? It can be represented in two forms as well. What is first is normal form, second is extensive form. See, what I mean is normal form. If we comes to normal form games, it's simple, okay? It's simple, and it's a form which is a simultaneous move. Players play a simultaneous move. It's done simultaneously. The strategies are taken simultaneously. I'm going to tell you what it means. Example, if it comes to playing, okay, you are playing a football or something, whatever game, you're playing football, okay, that's simple. Like you don't need to take decision like I'm gonna do this, I'm gonna do that, so to win there is nothing like that. You just go and you play, you try how much ever you want, you do physical first strength, and you will try to win. That's it. And there will be no order like he should first kick, then he should first, then he should be the next one to kick. Like that, there is no order for kicking it, right? There is no order for moving the ball from here to there. There is just no order. It's simultaneous and it's simple. There is no need to take and stress for our mind and take time for to do a strategy. It's a simple strategy, that is just I want to win, I should make sure that he doesn't come near to the ball. Just simple strategy, simpler and best way. That's called normal form games. And if it comes to extensive form games, let's we take the example. It's just I'm going to tell about the point that it's sequential move games, okay? It's done in a specific order. The decisions are taken in a specific order. It's let's say we take an example as an chess. If it comes to chess, first player take a decision, strategic decision by taking some time, that by taking some minutes or hours, then he moves one pawn from one place to another place. Then next player should play. That's the rule of the chess. It has specific order that first player should take a decision, then he should move the pawn, then next player should move the pawn after taking the decision. Then the second player should wait till first player does. Then after the if it comes to third player, the third player should wait after the second player finishes. Like this, it has specific order, sequential move games, and it is not simple. It takes time. It's like a complex way. We have to be careful every time. It's not simpler, okay? It's not. It does not see. We does not need to be in simple way to take a decision. Okay, let's go to the next point. Nash equilibrium. A fundamental concept in game theory is a Nash equilibrium, which is a set of strategies where no player can improve their payoff by unilaterally changing the strategies. See, by saying this sentence repeatedly, I try to make sure that change my voice in this sentence exactly because I want to show you this is the main important sentence whole line. This is main important line. This Nash equilibrium. Why? See, while playing the chess, you will be afraid that if I try to move this pawn, what he will think? What if he moves this pawn? At starting of playing chess, everyone thinks like this. What if he moves the same pawn? Then he is gonna win. Then I should change my strategy. I should make sure that I win, but I should use different pawn, different strategy so that he don't use second time once more repeatedly. Like that, he will make sure that he wins. Like that, he's going to change continuously his strategies by getting confused. That's called Nash equilibrium. Because of this, no player can improve their payoff. Means no player can lose or win. We can't guess which player wins or lose. First thing. Second thing is the players will be confused itself to win or lose. It's gonna be a draw or something like that. Okay, this is a Nash equilibrium. As I told you, simple in the chess way. Uh, you can you see it according to Nash equilibrium. It gives us it is crucial. Like like it does not tells exactly it's gonna get this much outcome. Example, if you once, if a play first player once is gonna get 10,000, that's a payoff. But the thing is, he's not, we don't know if you get 10,000 or not. It's a crucial play, it's a crucial playing game, or it's a crucial way to take a strategy. That's called Nash equilibrium. This type of strategy are called Nash equilibrium. Let's say it is zero sum games. In zero sum game, one player gains in is equivalent to another player loss. These games are often represented as matrices, and they are particular class of games. They have well liturgy. Okay, as I told you, while taking strategy, you have to take that, you have to take this. Mm. If a person take a strategy, okay, if a person wins, that person who first player who wins took a good strategic way, that's why he won. Then let's look at the second person, he lost, he should lose, right? If we comes to football game, if a person plays, then he wins. If a person who lost, did he lost or not? Yes, he lost. Every game has its own rule. Even if the rule changes, anything changes, it does not change one thing, that if a person wins, then another other persons accept that winning person should lose, should lose according to the rules of the game. That's called zero sum game. And the losing person payoff should be zero sum, zero. Okay, that's called the zero sum game, and it's represented. And if it comes to the um you know max symbols, if it comes to representing in a max symbols or something like that in mathematic way, it uses matrices to represent in a mathematic way. Okay, let's take it to the cooperative games. In cooperative games, player can form coalition and work together to achieve specific objectives. See, cooperative games, I'm going to tell you that uh, a company, A company, B company, let's take a company of this, has a project. A company, there is a company like A, okay, they decided to take a project, okay, but the companies are competing between themselves to take a project. So the bosses have decided to play chess. Let's we take that same example as previous example. The bosses have decided to play chess. They started to play chess, but the thing is, they don't want to be like, they don't want to play chess and make sure that their relationship get bad in the company. So they try to make sure that the in the field, in the present field which the company is established, they want it to be peaceful. So they cancel a thing called chess. So even if they play chess according to their rules, they created an agreement called, even if I win in the chess or lose in the chess, we are gonna we're gonna share our whatever we have profit, like whatever we got a project. If I am good at project, if I win, I am gonna make sure that project success, and whatever profit comes, we're gonna share between the companies even if we work hard. And you're gonna share your employees to make sure that they work for me. We're gonna just combine the companies like this, they become cooperative. Okay, this is called cooperative. There should be cooperative between everything to do anything in this universe, right? In the same way, if a player if a player is playing bit cards like bitting, or if a player is playing what is called card game, if a player if first player tells, like, I'm gonna win or I'm gonna lose, it's nothing to do with you, I'm gonna share profits if I win, can you do that, he is gonna offer something. Then second player also comes into an agreement with first player that if we win or lose in two members, if we two members win or lose, it doesn't have to do with anything, we are just gonna share profits with each other. This is called agreement, this is called cooperative games. They play a game with with agreeing and condition that they're gonna share whatever payoff comes to one of them. They won't do partiality. That's called cooperative games, as I told you. Then let's get to the combinatorial game theory. Okay, combinatorial game theory. This subfield of game theory deals with combinatorial games, which are distinct games with perfect information. An example includes game like chess and Go, and which play where players stay. See, if a chess player is playing a pawn, if a chess player is playing a pawn, is making a strategy or plan. Then next opposite player, he is good at playing. Then he knows what is chess, exactly what is chess and how to play chess. Then he exactly will and should know that what strategy a player is playing exactly now, so that I can play opposite one, so that I can win against him. That's called perfect information. If if a player, first player is playing a chess game pawn, then second player should not go that time anywhere and just neglect whatever he's playing and then come and play his side. He should sit there and watch whatever information, whatever pawn, which pawn he's playing, where he's playing, which place he's sat at their pawn. He should check every single information perfectly so that he could make a strategy, good strategy. And it should be a combinatorial games. Combinatorial game is a player where plays two, where two players will play. What is two players? Chess and Go. See, it's a Go playing is a Chinese playing game, Chinese or Korean. There is also called playing mahjong. Those all should have two players where a player observes every single information, perfect information, and those two players, it's like a zero sum game. If a person wins, then other person should lose. If one person lose, then other person should win. That's called the rules of this combinatorial game theory. And the payoff should be for two players. That's the rules of the combinatorial game theory. Okay, let's get to the next first slide. Oh, okay, the slide has ended. Here, my chapter is almost ended, but I told you. Okay, and as I was telling you, prisoner's dilemma, which I was gonna explain at last, which I told you that I'm gonna explain, where it describes a situation to play like wait, I'm gonna explain it clearly. Okay, it's a situation. Prisoner's dilemma is a situation where two players do or react for their selfishness. Example, if there is two players, player or a contestant who has an competitiveness on the first player, like he doesn't like the first player and he wants to bribe the second player so that first player can lose. He wants to bribe the second player and make sure that second player wins, and he also tell the second player that if you win, I'm gonna give you 10 lakhs, so make sure that you win and make sure that way they are gonna bribe the one other so selfishly to win or lose, which will result and what uh, uh, which will result in mutual benefit, but it's not a correct exact payoff which should be given. The payoff should be exactly the one who deserves. It should be given to who deserves. It cannot be bribed. But where a person bribes to each other so that their selfish uh, goals can be established is called prisoner's dilemma. Example, what's a real life example? Arms race between superheroes or local rival nations. Means it's they're just gonna do a war between a nations or a superheroes. Let's we take a nations example. They're just gonna do a war. Okay, if it comes to a war, a person wants to win. Okay, if a person wants to win, but the exact opposite person is so strong that he knows that he can't win. So he wants to make sure that exact opposite person wants to lose. So he's gonna bribe the second person, opposite person, and make sure that tell to the other nation that I'm gonna give you every hospital needed, every better treatment needed for the exact exact problems you have. I can give you the dams or water rivers to your side, to your country, or half of the country to you, so that you can leave our country alone, safe and sound. Like this they're gonna make cooperate. So like this they're gonna cooperate each other and make sure they bribe each other and betray each other and somehow make a mutual benefit from that. But to avoid an arms race, they were gonna cooperate. Like this they are gonna get the payoff in an so like so selfish way, so unjustice way. So this is called the prisoner's dilemma. Okay, thank you. This is it for today. As I told you, it's an example of princess dilemma because while taking a decision, while taking a strategic decision, they stop the strategic decision and make sure that they take a decision of in a way that they can win compulsory or they can lose compulsory. See, if a strategic decision, if a person takes, then it depends. We can't know if a person wins or lose. But if it goes to prisoner dilemma, a person can exactly guess if he can lose or if he can win because he knows he bribed the other person. He exactly knows what wrong he's doing, right? So that's the way prisoner dilemma is gonna play a role in game theory. Okay, thank you. Let's just stop the this till here. Thank you for